called as static polymorphism. Because the binding is done in the compile time, it is called compile time. Because there is no changes in the method calls, it is called as static. That's why we call it as a static or compile time polymorphism. What comes under this? Sleeping in the classroom, huh? Open the mouth and answer. What comes under this? I said to you. Overloading here. What am I sleeping? Are you not listening to the class at all? Body present and mind absent. Starting, I said to you. Overloading comes under compile time polymorphism. Okay. So what comes under this? Overloading. So when the binding is done? Compilation time. Binding is done at the compilation time. So we call it as compile time polymorphism. The identification is done in the compile time. Okay. And there is other name for it. What is the other name? Static. Why is it called static? Because what is bound, that only will execute. No changes again in the future. What is bound, that only will execute and no changes in the future. That's why it is also called as static. What is the second one? Dynamic or runtime polymorphism. The second one is a dynamic or runtime polymorphism. What is dynamic or runtime polymorphism? Guys, in dynamic or runtime polymorphism, what happens, you know? In dynamic or runtime polymorphism, what happens is overriding comes under this, guys. Overriding comes under this. Actually, in dynamic polymorphism, which polymorphic method has to be executed will be identified not in the compilation time, will be identified in the runtime. I repeat, in dynamic polymorphism, which polymorphic method has to be executed will be identified not in the compile time, will be identified in the runtime. In the runtime, it will identify which method has to be executed here, not at compile time. It identification is done in the runtime. Why, sir? Why is it done in the runtime? I'll tell you. I'll tell you why is it done in the runtime. Watch this. Class parent. Okay. Here I'm writing public void show. Console dot write line. Parents method. Simple code. Parents method. Next, public virtual void test. Okay. So simply I'm just going to write here as a okay. Parents show method. Parents test method. Now guys, this method is declared as virtual. So can the child class override the method or not? This method is declared as virtual. Can the child class override the method or not? Can do na? It can override the method. Open the mouth and answer here. Don't nod your heads like this. I'm not looking at you. I'm looking on the screen. If you nod your head, I don't understand. Open the mouth. You're not LKG kids. Okay? Yeah. Now I'm writing another class here. Class child colon parent. I'm defining a parent class. Sorry, child class. Now guys, watch. Here I'm writing a method. What is the method? Public void display. Right line. What? Child's display method. Child's display method. Okay, concentrate on this, all of you. Actually, child class has a choice. Child class has a chance to override the test method. Child class has a chance to override the test method. Even though it has a chance to override the test method, now it did not do that. Now it did not do that. So it did not override the test method. Which method? The test method is not overridden by the child class. Is it clear, all of you? So totally how many methods are there in the child class now? I said you that only. Open the mouth and answer. 3. Brainless fellows. 3 methods here. Show, test, display. You forget already about inheritance. Telling 1 method, 2 method. 3 methods are there. Show method, test method, display method. Now, let me define another class here. Class test classes. Writing a main method, void main. Create the instance of child, new child. C.show will execute the parent class show method, right? Correct? C.display will execute child class display method. Will execute child class display method. Fine. Same way, C.test will execute parent class test method. Will execute parent class test method. Show is from parent. Put your brain there. Show is from parent. Display is from child. Test is from parent. Not defined in child, so it is from parent. Are you clear? Now I am compiling the program. When I am compiling the program, what happens, I said you, in static polymorphism, what I said at the time of compilation, compiler identifies this method call should execute which method and it will bind it now. This method call should execute which method will bind it. In static polymorphism, overloading, I said you, it will bind off. When it will bind at the time of compilation. Now see, I am compiling the program. C.show. Where this method is? In the parent class. Where this method is? Parent class. It is in the parent class now? Yes or not? Because the method is present in the parent class, what happens, this is going to be directly bind the call to show. This is going to bind to the parent class show. Okay? Now C.display. Where is it? Child class. This will bind to child class. This will bind to child class. Are you clearer or not? Okay? But when you call C.test, binding won't be done. When you call C.test, binding won't be done. Why? The method is declared as virtual. The method is declared as virtual. Because the method is declared as virtual, the binding will not take place here. The binding will not take place here. Why the binding will not take place? The reason why the binding will not take place is because the method is not overridden in the child class now. But what is the guarantee? It is not going to be done in the future. Do you have any guarantee the overriding will not be done in the future? Tell me. Chances are there that overriding can be done in the future or not? This method overriding can be done in the future. There is 100% chance the method can be overridden in the future. So tomorrow if the method is going to be overridden in the future, problem starts now. Why problem starts? Because if it is overridden, child class method should execute, not parent class. Now I am binding this call. To this method. Tomorrow if you override also, parent class method only will be called now, not. But what should be called here? Parent or child? If it is overridden in the child, parent should be called, child should be called. Child should be called. If it is overridden in the child, what should be called? That's what we saw yesterday here. Before overriding parent, after overriding child. Child should be called. But what am I doing? Compilation time, I am binding this call to this method. Compilation time, I am binding this call to this method. So if you override in the child also, it won't call child class method. What method will execute? Parent method will execute. What will execute? Parent method will execute. Are you clear? That is the reason why when it finds the word virtual there, it will not do binding at all. It will not do binding at all. Then what happens, sir? Now in the runtime, no binding happened for test. Binding happened for show. Binding happened for display. But binding did not happen for test. in the runtime, what happens, when you call c.test, first it goes to child class, verifies, is the method available? No. Then it will go to parent and executes the parent class method. Tomorrow, after 1 month, the method is overridden in the child. Now this verification first always goes to child only. Now it finds the method. Will invoke the child class method. Otherwise goes to the identification of which method should be called is done not in the compilation time. The identification which method should be called in the runtime, not in the compile time. That's what we call as runtime polymorphism. Identification done in the compilation time is compile time polymorphism. Identification done in the runtime is runtime polymorphism. Okay? Overloading is compile time or runtime? Overloading is compile time or runtime? Compile time. Overloading is compile time. Overriding is runtime. Overriding is going to be runtime polymorphism. Is it clear? Okay. Someone asked a question here. What is meant by compile time and runtime? What did you learn here? You learned C language. You don't know what is meant by compilation and running the code. Compilation is like cooking the food and runtime is eating the food. Compile means you're just preparing the food. Runtime means you're executing it now. Child class has an option to do. In case it is child also, then it is binded, sir. In case it is child also, it won't be binded. Why it won't be binded? Tomorrow I'll remove the method. Tomorrow you're binding. See, there's a question. Sir, if I overwrite this in the child, will it do binding? It won't do. Why? Tomorrow if I remove the method, and after overriding, after 1 month, I thought I don't want this overriding, I'll remove the method now. Then it should call child or parent. If the method is removed in the child, it should be calling child or parent. Parent. That's why that identification will always be done in the runtime only, not in the compilation time. Even this same process, it can do compile time, why it is doing in runtime. I did not understand, Raju. If it can do in the runtime, why will it do? It can do in the compile time. Why will it do in runtime? It cannot do in the compile time. That's why it is doing in runtime. It cannot do in the compile time. That is why it is doing in the runtime. That's what I said to you. Clearly said to you. If it does in the compile time, what is the problem? If it does in the compile time, tomorrow, if the method is implemented in the child class, what will you execute? Parent method will execute. Child method won't execute. So this identification should be always done in the runtime only, not in the compile time. In the runtime check. What check? Is it overridden by the child or not? Yes, then call child method. No, then call parent method. Binding to two methods is not possible. Binding to one method is only possible. That is why where binding to one method is possible, it is doing in compile time. Where it is not possible, it is doing in runtime. If override or any change happens to code when do compilation, so can bind in compile time, no sir. No, I won't compile. I won't compile this code. This is in another project. Raju, I won't compile this class here. You are telling we'll compile now. You will compile this code. I won't compile this code. What will you do now? Okay? I won't compile this code, but it's already bound to parent. So it will go and execute parent only. It won't execute child now. See, the designers are not fools. They just think each and every point. They think each and every point and they design it. Are you clearer or not? So did you understand runtime polymorphism? Identification of which method should be called if done in compile time, that is called as compile time polymorphism, and if done in runtime, called as runtime polymorphism. Runtime is called dynamic, na? Why dynamic? Why dynamic? Array, it is calling either child or not the same. Remember, it can call a child method or otherwise parent method. It can call the child or parent. Yes. For virtual methods only, that will go for runtime. For all other methods, that is compile time only. For all other methods, that is compile time only. Only for virtual methods, that will be done in the runtime. For other things, it will be happening in the compilation time. Okay? Or otherwise, you understand this. This will be the correct way you can just understand. Watch it. Parent P is equals to C. What is P? Parent class reference. Parent class reference. Created by using child class instance. Correct? Huh? Watch it, all of you. C dot, not C dot show. P dot show. P dot show will directly go to here. Executes this method. Right? Yes or not? Okay. Now you are calling P dot display. P dot display. Understand? P dot display. Which method is called? Fast. That's why I scold you every day. Brainless fellows. That is invalid. Yesterday also said, that is invalid. You can't call child class members by using parent reference. We cannot call child class members by using the reference. Okay? And now you see P dot test. P dot test. Which method is called? Because it is not overridden in the child, it will call parent method only. But if it is overridden in the child, we'll call child method. Are you clear? Because it is not overridden in the child, which is called parent. It is overridden in the child is called. Yesterday that only I stopped it. The parent reference can recognize the child class overridden members. If this recognition should be done, it cannot be done in the compile time. This can be done only in the runtime. This can be done only in the runtime. So remember, polymorphism is two types. One is compile time. One is runtime. What comes under compile time? Overloading. What comes under runtime? Overriding. Now you'll have a doubt. Sir, what about hiding, sir? Hiding doesn't come under anything at all. Why? Because according to object-oriented programming standards, there is no concept called hiding at all. What they have is only overloading and overriding, but they don't have anything called hiding at all. Hiding was introduced by Microsoft in its C# language. So that is purely a feature introduced by Microsoft in the C# language. That is why that doesn't come under compile time polymorphism, or that doesn't come under runtime polymorphism also. Are you clearer or not? Okay. So according to object-oriented programming, what is present? Only two are there. What is that? Overloading, overriding. But there is nothing called hiding or shadowing. Hiding or shadowing is purely introduced by Microsoft in its C# language. That's all. In its .NET languages. That's all. So we don't require to talk more on that particular hiding. So it comes under compile time, it comes under runtime, no questions about it. That doesn't come under any of these two. Okay? And did you understand why the word dynamic also? It can either call child or parent. That's called as dynamic. Either parent or either child. That's why we are calling it as dynamic. Okay? So these are the two types of polymorphisms that are available to you. Static polymorphism and dynamic or runtime polymorphism. Okay. So you can see static polymorphism. Occur set, compile time. Occur set, runtime. Achieved through static binding. Achieved through dynamic binding. Overloading should exist. Overriding should exist. Overriding means compulsory inheritance. Without inheritance, no overriding at all. Nah. Only happens in the same class. Inheritance is compulsory, we said. Nah, that's what happens between parent-child classes. Next. Reference creation through? Not required. Reference creation through. But here? At all. Parent class reference created by using child class instance. So these are the differences what we come across between overloading and overriding, or static or dynamic polymorphism. Are you clear with polymorphism? So today, let me show you practically how polymorphism is used in your applications. Means I'll show you practically where overriding and hiding are used. Where overriding and hiding are used. Okay, now? Look at this, guys. It's going to be a bit interesting as well as confusing also. Just be concentrated. Don't look into your notes. Concentrate here only completely. I am defining a class here, guys. I am naming the class as matrix. Actually, my intention is I want to define a class that represents a 2 by 2 matrix. I want to define a class that represents a 2 by 2 matrix. See, you defined a class representing a student. You defined a class representing a staff. In the inheritance video you watch it now, student 1 class, staff 1 class, teaching, all represents entities. Now my entity is matrix. Now my entity is matrix. What matrix? A 2 by 2 matrix. So I wanted to define a class representing a 2 by 2 matrix. Okay now? So let me name the class as matrix. So what is it? 2 by 2 matrix. 2 by 2 matrix means how many attributes are required? Tell me. 2 by 2 matrix means how many attributes? You know mathematics or forgot mathematics? Huh? How much time you want here to tell that? Public matrix. Int A, comma, int B, int C, int D. This dot A is equals to A. This dot B is equals to B. This dot C is equals to C. This dot D is equals to D. I did not write anything new, guys. I declared 4 attributes and initialized in a constructor. Now, can I create the instance of this class in another class? Yeah, wherever you want, you can create it. No problem. So let me add another class in the project. I will name the new class as test matrix. Test matrix. In test matrix, I'm just going to create the instance of the matrix. Matrix M is equals to new matrix. Okay. And it requires attributes now 20, 19, 18, 17. Clear? Now when you created the instance, all the 4 attributes of the matrix are initialized or not? Tell me. All are initialized. Okay. Now I'm just going to do a small thing. Watch it. This is a matrix class instance. The instance takes what? 4 integers as a parameter. The integer instance takes what? Same way, string class here. String is a class. String is a, already said you, string and object are classes. String is a class. This class string as a constructor, guys. The class string as a constructor. And what the constructor takes, you know, the constructor takes a character array as a parameter. Array, here this constructor is taking 4 integers as a parameter and building a matrix now. The string class constructor takes what? Character array as a parameter. So what I can do, you know, I can pass a character array here. How? New character array, and I'm passing H. Understood all of you? What am I passing? Unnamed instance. Yeah, I already explained about this. A new operator, unnamed instance. Directly you can create off. No need any name for it. So now it will create a string now. So the string is created now with this character array. Now guys, after doing this, if I say console.writeLine S1. Console.writeLine S1. Watch it. When I say console.writeLine S1, it will print me. I did not set the startup object. Yeah, I did not set the startup object. Concentrate. When I print it, it is going to print me the value of the string now. Array, internally with these characters, a string is created now. With these characters, a string is created, and when you run that, string is printed on the monitor now. Same way, when I create an instance of the matrix class by passing already internally, when matrix is created, internally when matrix is created and all the four attributes are initialized. But see, watch it guys, when I say console.writeLine M1, I'm expecting to print the values of the matrix now. I'm expecting it to print the values of the matrix. But see guys, it's not printing. What's it printing? Name of the class. What's it printing? Name of the class. It's not printing the values of the matrix. Are you understanding my point here? When I created a string class instance passing a character array, it internally created one string and printed me. When I created a matrix class instance passing the four values of the matrix, internally matrix is created but not printing. I want to see the matrix values now. Did you get my point or not? First question is, sir, why is it not printing? Why is it not printing? Because I already explained you a number of times. A computer is a brainless machine. It doesn't do any actions on its own. It will perform every action based on the instructions that are given to it. That's all. Are you clear? A computer is a brainless machine. It doesn't do any action on its own. What it will do? It will only perform the actions based on the instructions that are given to it. Understood my point or not? So that is why the instruction what is given to the computer is, when you try to print the instance of a class, when you try to print the instance of a class, print the name of the class. Are you clearer guys? When you try to print the name of the class, when you try to print the instance of a class, print the name of the class. That is the instruction given to it. Are you following my point or not? Okay. If that is the case, sir, S1 is also instance of string. Na? If M1 is an instance of matrix, S1 is an instance of string. Then here also it should print the name of the class only. Na? Then why is it printing me the values? Why is it printing me the values here? And why is it printing the name here? Are you getting my point or not? So listen guys, why is it printing the values and why is it printing the name? This will be the big question in our minds. Okay, let me clarify. See, to print the values, which method did you call? WriteLine. Where is it defined? Console class. Where is it defined? How many overloads are present for the WriteLine? Day before yesterday I said to you. How many overloads are present for the WriteLine? 18. Online students are better than you. You're directly listening and don't remember anything. 18 overloads are there. I shown you also. How many? 18 overloads are there. Okay. See, look at this code. I'm not writing the console class for you. I'm only showing you how the console class was defined in the libraries. Okay. See, in the libraries, console class was defined as following. It's defined as following. Look at this. Public. Do you remember this one? It is a static class. Already shown you. Public static class console. Every member in the class is static only now. Okay, let's focus on the WriteLine method. How many overloads are there? 18 overloads. The first one is the WriteLine without any parameters. The WriteLine is without any parameters. Public void WriteLine, no parameters. Here, code is implemented. Code is implemented to print a line break. The code is implemented to print a line break. Okay. Same way, WriteLine, which takes int as a parameter. WriteLine, which takes int as a parameter. Code is implemented to print the integer and line break. It will print the integer and a line break now. Same way, there is a WriteLine method which takes double as a parameter. A right line method which takes double as a parameter. What is the logic here? Code is implemented to print the double and line break. To print the integer value and line break. Here, double value and line break. Same way you say string S. String S. Print what? String value and line break. Okay. Now, all of you concentrate on this. When you are calling console.writeLine S1, you are invoking the writeLine method which takes string as a parameter. Correct? Tell me confidently. Now, listen. The control comes here now. What is the logic? See? They implemented logic to print the string value and line break now. Are you clear? That is the reason why the string is printed on the monitor to you. The string is printed on the monitor. Okay? Now, all of you observe. This will call the writeLine method which takes string as a parameter. Now, my question is, when I call console.writeLine M1, here it is calling the writeLine method which takes string as a parameter. Now, you tell me here, which writeLine method will execute? In the 18 writeLine methods, which writeLine will execute? Second one I clearly said you. Second one will call the writeLine method which takes a string as a parameter. Now the first one will invoke which writeLine method from the 18 methods? Which one will execute? Int. M1 is int. M1 is not an int, na? How are you telling int? Param array. No. Why param array? Varchar. Where did you get varchar from here? Object here. Object as a parameter. It will call the writeLine method which takes object as a parameter. How, sir? Object is a parent of all the classes, na? Yes or not? See, listen. You have a writeLine method. You have a writeLine method here which takes object as a parameter. Public void writeLine object obj. There is a writeLine method which takes object as a parameter. See, look at this, all of you. I am calling console.writeLine S1. S1 is a string. Correct? Now it checks with the first method. Does it matches? No. Does it matches? No. Does it matches? No. Does it matches? Yes. Stops there now and executes that logic. Okay. Same way you're calling console.M1. Again, same story repeats. First one, does it match? Tell me fast. No. Does it match? Louder. This one? This one? Yes, sir. That is string. So like this, none of the 17 methods will match now. None of the 17 methods will match. If nothing matches, this will match with everything. Why this will match with everything? That only here we learned in object-oriented programming. Object is a parent class of all the classes, and the child class of any class can be assigned to the parent class variable. Are you clearer or not? Object is the parent class of all the classes, and the variable of the child class instance can be assigned to a parent class variable. Possible na? Now see, matrix class instance can be assigned to obj now. So what happens, this M1 comes to obj, and obj is a reference now. Are you clearer or not? M1 assigned to obj, and obj is a, I said your reference and you're telling object again. Obj is a reference. Now it's a variable first. That declaration only na. So now here what is M1? M1 is object. When I call writeLine M1, I'm passing the object. I'm passing the object to the method which is assigned to obj. And obj becomes a reference. Obj becomes a reference. Are you clearer or not? Understood my point? See guys. So if you remember, in the inheritance class I said you, whenever you create the child class instance, it will read its parents' information and identifies the members. Yes or not? So first what happens? You created matrix class instance. When you create matrix class instance, what is the parent of matrix? How many parents matrix has? One only. Which one? Object. Because we did not inherit anything, only the default parent is matrix. So now here it was going to gather the information of both the classes. It is going to gather the information of both the classes. So this is the instance created. Observe guys carefully. This is the instance created. Now in this, what did I say? It will have the information of first which class? Object class. Yeah. What is first class, guys? Object. So the object class and its members are recognized. Come on, all of you, tell me what are the members of object class? Equals, get hash code, get a type, and toString. It recognizes the members of the object class now. Next it comes to matrix class. Next it comes to and identifies the members of the matrix class now. Identifies the members of the matrix class. What do you have in matrix? In matrix class here you have 4 fields there, that's all. You have 4 fields there, that's all. To be clear, you can also have, you have a constructor. You have a constructor. Or I did not point you, but here also constructor will be there. Every class will contain constructor. Nah. Every class will contain the constructor. So when you guys created the instance of the matrix M1, when you guys created the instance of the matrix, what is that? M1. This is M1, guys. What you have created? Just a second. This is this is your M1, what is created. And I explained all these things in detail for you in the inheritance. When you create the instance of a child class, it will first go to the parent class, identifies the members of it and records it. So the recording, see, first what is the parent class? Object. It recorded the information of the object class. Afterwards, matrix class. Okay. What is the name of it? M1. Now see, when I call console.writeLine M1, this M1 is now sent to, the M1 is now sent to where? This method. Captured in OBJ. This is captured in OBJ. Now all of you guys observe it. What is this? Your OBJ also starts pointing to the same memory. So here what you have? Is that clear? This is OBJ. What is OBJ? Instance or reference? Reference. What is M1? What is M1? M1 is a instance, but OBJ is not a instance. OBJ is a reference. So now if you guys observe this OBJ is consuming the memory of M1. It is consuming the memory of M1. Are you clearer or not? Okay. Now listen. So which method is executed? Which method is executed? It is going to execute the writeLine method, which takes object as a parameter, and M1 is assigned to OBJ, and now OBJ and M1 both are started pointing to the same memory location. Both of them started pointing to the same memory location. But remember, this instance and is a reference. Okay. Using OBJ, can I call the members of matrix? Using OBJ, can I call the members of the matrix? Fast, yaar. Using OBJ, can I call the members of the matrix? Every day you forget. What should I say you? Yaar, parent cannot call child members. How many times I should tell you? Again, you say same answer. Yes, sir. Parent cannot call child members, na? Then why you are telling yes, no? You can call only overridden members. Do you have any overridden members now? Tell me faster. Don't open the mouth, sir. I'm scolding you, but you're not behaving. You're not opening the mouth, sir. Tell me faster. Do you have any overridden members now? No. All are pure child only, na? Parent reference can call child member, huh? No. OBJ cannot call any member of the matrix class now. OBJ cannot call any member of the matrix class. Not at all possible. Okay? Now see. What is the code inside of this method? See here. For this method, I said you the code. Here the code is implemented to print a line break. Here the code is implemented to print the integer value and line break. Here the code is implemented to print the double value. Here the code is implemented to print the string value. Then what is the code implemented here? Look at this, guys. What is the code? The code is string type name is equals to obj dot toString. It will call a method called toString. It will call a method called toString. Listen, what's the picture? The toString is a method present in object class. Yes or not? That is inherited to all the child classes. That is inherited to all the child classes. When it calls obj.toString, the toString method returns the name of the type to which the instance belongs to. What it returns? I said you na. What it returns? The name of the type to which the instance belongs to. What it returns? The name of the type to which the instance belongs to. Or it returns you the owner name for this memory. Who is the owner of the memory? Which class? M1 is not a class. Matrix class. M1 is object. M1 is instance, not a class. Which class? Matrix class. I repeat again. What it returns you? The name of the type to which the instance belongs to, or this memory belongs to. It belongs to matrix class. That's what it returns. Matrix class is defined in which namespace? Oops project namespace. Which namespace? You define matrix class in oops project namespace. Okay? So that is what. So what will this contain now? Oops project dot matrix. What it contains? Oops project dot matrix. Afterwards, it will call write line type name. Type name is which type? Type name is a string type. Now you are calling write line of string. When you call write line of string, control comes here now, and you have already code available here to print the string now. Are you getting me? I given you an answer to you. Why did it print the class name on the screen? Did you understand my point now? Why class name is printed on the screen? Because in this method, what is happening? It is calling toString. ToString will return the type name, and that type name is printed by this method. I called this method, guys, and this called this method and printed me the output on screen. So that is why when I run this code, what you are seeing now? Are you clearer, all of you? Yes or not? Okay, it's a very, very important concept, guys. Remember, you can never print the object or instance of any class. We can never print the, I don't say never print. Sorry, I don't say never print. Just listen this. If we try to print the instance of any class by calling write or write line methods, okay, it will print the name of the class to which the instance belongs, but not the values that are associated with the class. Read that, all of you. If we try to print the instance of any class by calling write or write line method, any method here, you may call a write method or you may call a write line method. That's your choice. By calling a write or write line methods, it will print the name of the class to which the instance belongs, but not the values that are associated with the class, are associated with the, that's the correct word. It won't print any value. That's why M1 is associated with 4 values, guys. What are the 4 values? 20, 19, 18, 17. But it did not print you that. What it printed you? Class name is printed. Are you people clearer or not? First tell me, who returned that class name? Come on. Watch the code. Watch the code. Who returned that class name? Who returned that class name? Two-string method, yaar. Who returned it? Two-string method. Who returned it? Are you clear? That returned and you are capturing, see, type name is equals to, that method returned the value. You captured it now. Who returned it? Two-string. Where this method is defined? In the parent class of matrix. In the parent class of matrix. Are you following me? Who returned the type name? Two-string. Where is it defined? In the parent class. That is object class. And now, guys, I did not like the behavior of this method. I did not like the behavior of this method. This method is returning what? Type name. I did not like the behavior. What did I say yesterday, guys? If you don't like the behavior of a parent class's method, we can change that behavior in 2 different ways. What are the 2 different ways? If the method is declared virtual, use overriding and change the behavior. If the method is not declared virtual, use hiding and change the behavior. That's what I said to you yesterday. Are you getting me or not? Okay. Now tell me, object is the parent class to matrix or not? Confidently. Object is the parent class to matrix or not? So now, in the matrix class, two-string method is there. That returning the type name, I did not like that. I did not like that. Because I did not like that, can I override this in the child class? Can I override that method in the child class? Parent class method is two-string here. Can I override this in the child class or not? Yes, sir. Provided if it is virtual only. You should. The answer is you cannot confidently say yes also. Yes, provided the method is virtual. If not declared virtual, you can't override. If not declared virtual, you cannot override. When can I override? If the method is declared as virtual only, I can override. If not declared virtual, then I should go for hiding. If it is not virtual, I should go for hiding now. Yesterday, I clearly explained you this concept to you. How to know a parent method is virtual or not, I said you. How to know, I said you. Here type override. Immediately it will show the list of the parent class methods which can be overridden, which are virtual. That will show for you yesterday. I explained you already. Now look at the list and tell me, two-string is virtual or not virtual? Tell me here. Yeah, the list is coming here. The list is showing you two-string. Means two-string is virtual. Get type. Get type. Get type is not virtual. That's why it's not coming. Equals, get hash code, two-string are virtual. Get type is not virtual. Two-string, get hash code, and equals are virtual. Get type is not virtual. So these 3 methods you can override now. Which method are you planning to override? Two-string. Which method? Two-string. When I do that, guys, it will by default say return base.toString. Return base.toString means again it is calling the parent class toString only. No, I don't want. I want to write my own code. What do you want to write? Hello world. What I'm writing? Hello world. Now guys, come to this picture. Come to this picture. Now tell me, there is a toString method in the matrix class also or not? Ray, you done it now and you're telling no again, brainless. You done it now. What did you do? Over that only I'm asking you. Do you have a toString method in the matrix class now or not? Yeah, I have a toString method in the matrix class also. I have a toString method in the matrix class also. Overridden. Overriding or something, whatever you do, but that method is present in matrix class. Agree with me? Yes or not? It's a pure child class method or overridden method? Overridden method. Now tell me, if I call obj.toString, it will call parent method or child method? If I call obj.toString, it will call parent method or child method? Child method. Why parent? Child. Array. Overridden members from the child gets called, not pure child. Pure. Yesterday that only I shown you. Pure child members are never called. What is called? Overridden members. So toString is overridden member now. So because toString is overridden, when I say obj.toString, it will call child class method. Dynamic polymorphism. Nothing but dynamic polymorphism. Which method is called? Child class toString. Now guys, all of you, observe it. When I call obj.toString here, it will not execute the parent class toString method. What it executes you? Child class toString method. What it returns? Hello world. What it returns? See now what is printed. Now run the code and see what is printed. It's not printing the class name, guys. Watch. Just a minute. It did not still print the result. System became very slow. What is printed? See? Hello world, not class name. Did you get me? Array, that only I'm telling you, yeah. Put your brain there. What I'm telling is, computer will only perform actions that are predefined. Till now, the computer knows if you try to print the instance of a class, call the parent class toString method and execute and print the type name. Now also it is doing the same thing. But what did I do? I changed that one now and said, don't call parent class method, call the child class method. I will write my own logic. So call that. So now I have written what? Hello world. Computer doesn't decide anything on its own. I should tell everything to the computer. Whatever I say, that only it will do. Okay. So now listen. Come back. Come to this point. Yeah. See that point again? If we try to print the instance of any class by calling write or write line methods, it will print the name of the class to which the instance belongs, but not the values that are associated with the instance. Okay. And see the reason why it prints the name of the class is internally the write line method calls toString on the instance and identifies the name of the type to which that instance belongs and prints it. Read the second point now. The reason why it prints the name of class is, internally the write line method calls which method? toString on the instance and identifies the name of the type to which that instance belongs to and prints it. Okay. Where did you get the toString method from? As we learned, just a minute. We have already learned in the Fourth rule of inheritance. Fourth rule of inheritance, that every class has a default parent, that is, what is that? Object, and that object and that class contains, and that class provides four methods to all the child classes. What are those? Equals, get hash code, get a type, toast. So the parent class's toString method is called to identify the type name to which the instance belongs to. Come on, guys, read all the 3 points and tell me if you have any doubts anywhere. Come on, read all the 3 points and tell me if you have any doubts anywhere. Understood? Yes or not? Any question? Tell me. Understood? What method is called? toString. Where is it present? Object class. And that is going to print you the name of this. This is the reason why it will print you the class name but not the values. Okay? Now see. If we wanted to print anything other than the class name, we need to override the toString method in our new class, and implement the logic we want to be printed when we try to print the instance of class by calling right line. See here, very simple here. I will call right or I'll call right line. That will call toString. I am not calling toString. Who is calling toString? Right line is calling toString. Is it clear? Who is calling toString? Right line is calling toString. By default, right line will call which toString method? Object class toString. But if that is implemented in the child, if that is overridden on the child, it won't call object. It will call child. Why it will call child? That is what I explained to you in the concept of the dynamic polymorphism. What is the dynamic polymorphism? Just a minute, guys. Now see, here you have another thing here. What is that? ToString. Array, till now, you have what? A, B, C, D and a constructor. Now you have toString also. So now tell me, you have a toString method in the parent, you have a toString method in the child. Overridden. Now this obj will call parent method or child method? Obj will call parent or child? Child. It will call the child. Why it will call child? Overridden. It is hiding. If I perform hiding, will it call child? Yesterday I shown you na display. Parent is called. So child is called. Now also, if toString is performing overriding, child is called. No, it is not overriding. It is hiding. The method is not declared as virtual. Then it will call you parent. If overriding is there, what is called? Child is called. So now, when I say obj.toString, this method will execute. So here, see all of you, you are calling C obj.toString. When you say obj.toString, the control will come to the child class toString method and executes the logic in this method. What did you write in the method, guys? Return hello world. What did I write? Return hello world. Actually, to make you understand, I've written you something, but I don't want to return hello world. Then, array, I wanted to print, my intention is to print the values of the matrix. My intention is to print the values of the matrix. Understood? So let me print the values of the matrix. Come on. How to print? Array, what type of matrix here? 2 by 2 matrix. Correct? Huh? So A plus space plus B plus slash n plus C plus. Did you understand me? This is why the computer won't print here. Why the computer is not printing, You declared four attributes now for a 2 by 2 matrix. You know, I know. How computer know that is a 2 by 2 matrix? Is your brain connected to computer? Is your brain connected to CPU? So that if you think in your brain, computer will understand the 2 by 2 matrix. How do computer know? Yeah, that's why computer won't print you. It don't know. Your expectation is a 2 by 2 matrix, 1 by 4 matrix, 4 by 1 matrix. How does computer know that? Is it clearer or not? That is the reason why computer will not do any action on its own. If a computer should do anything, I should tell the computer. Now I'm telling to my computer. What I'm telling you? Print it in a 2 by 2 format. Now see the output, all of you. Got it? Remove that string there. I declared a string here. Now remove that. That's not required. A 2 by 2 matrix. Is it clear? Now see, I'm going to create you multiple instances. M2, M3, M4. Sure. 12, 10, 9, 8, 7. There are 4 separate instances, guys. See now. Printing all, but this is looking like a 2 by 8 matrix. It's not looking like a 2 by 2 matrix. It's looking like a 2 by 8 matrix. Let's add one more line break here. Watch. Is that clear? Yes or not? Now I'm giving a task to you. Can you write me the code for a 3 by 3 matrix? Write the code for a 3 by 3 matrix. Define a class. What is that? A matrix class. How many attributes? 3 by 3. 9 attributes. You need to define a constructor and initialize all the 9 now. And now you need to overwrite the two-string method, and you're required to write the code for printing the values of like a 3 by 3 matrix. Clearer or not? The output should be generated for you like a 3 by 3 matrix now. Okay, so this is a live example for you. Why do we override methods? If I don't override, you can again see. If I don't override, what will I get? If you are satisfied with the output, don't write. Are you satisfied with the output? Tell me, guys. Are you satisfied with the output? If you are satisfied with the output, don't write. No, sir, I am not satisfied with the output. You are not satisfied with the output now. Then what you do? Override the method. So last day, when I was explaining about overriding, this is what I'm telling you. Array, why it is the need of overriding? I'll tell you, wait. I'm not okay with the output. I'm expecting something different. Whatever you're expecting, you write it in the two-string method by overriding it. So now the new thing will be printed for you in the place of old. Okay. So finally, the last point, what I'm trying to tell you now. Whenever you define a class and want to print the values that are associated with the class through the instance of class by calling write or write line methods, then you need to override the two-string method and implement the logic for printing the values as per the requirements. That is the final conclusion for you all, guys. From today onwards, you'll be writing so many classes. You want to print the values of the class, then override the two-string method in the class. No, sir, I don't want to print. Then don't override. You want to print, then override two-string. Is it clear, all of you? Okay, what is that? Whenever you define a class, whenever you define a new class and want to print the values that are associated with the class through the instance of class by calling what? Write or write line methods, then you need to override the two-string method and implement the logic for printing the values as per the requirements. So this is the final conclusion you have about this. Okay, if you have any doubts on this still, there is a video on this particular thing also. There is a video on this matrix class, overriding the matrix class, or overriding the two-string method for all the things. I also posted a video on this. You can just watch that. Is that clear? Let's stop it here. We'll meet tomorrow.